Okay, pre-cal, we are on the top of page 5 of our notes, and our last video was about symmetry. So if you will notice up here our rules that we have, we know it's even when f of negative x equals f of x, and we know it's odd when, oh, my handwriting's terrible, sorry, when f of negative x equals negative f of x. Now, when we're looking at this up here, it seems pretty reasonable when we looked at the graphs, right? Because it's a lot easier to determine what's happening based on the graph than it is algebraically. So this is going to be tricky for some of you because we've got our function here, but we want to know if this is an even function or an odd function. So that's what we're trying to determine. Well, if it's even, I know that f of negative x is going to equal f of positive x. So what does that mean for me? Well, the original f of x is the example that you're given. This is x squared minus 5. Now, some of you probably recognize this as a parabola that's been shifted down 5, so you already know that it's got axis about the y, or symmetry about the y-axis, so you already know it's even. But when we're determining this algebraically, I need to find f of negative x right here because I want to know if it's equal to my original equation. So I'm going to find f of negative x. So everywhere I see this x right here, I'm going to replace it with negative x. So I'm going to use parentheses for substitution always. Okay, so f of negative x equals negative x squared is positive x squared minus 5. Okay, so if you will notice, f of negative x is equal to x squared minus 5. Well, what is f of x equal to? Well, f of x is also equal to x minus 5. That means that these two are equal to each other. So you have y-axis symmetry, and it is even. That's how you do this algebraically. Okay, so let's move on to our next example. We have g of x equals x to the cubed, minus 1. So we are trying to determine what kind of symmetry we have here. Okay, so this is my original function, g of x. Well, I'm always going to try to see if it's even first because the even has the f of x in it already. So if I can determine if that is equal to g of negative x, I can go ahead and say it's even. So I'm always going to try that one first. So let's find g of negative x. Again, I'm going to use parentheses when I substitute in negative x for x. Be careful with that. So I've got g of negative x equals, when I cube negative x, I get a negative x cubed. Oh, what happened? I lost control, kids. That's a big surprise. Okay, so I have this right here. Well, if you'll notice, g of negative x equals negative x cubed minus 1, but g of positive x equals x cubed minus 1. These are not the same because of this right here. See this? There's no negative up here. So that means that for this problem, g of x is not equal to g of negative x. That means it cannot be even. So I'm just going to mark through y-axis symmetry and even because it can't be that. So that leads me to this right here. So if it's not even, maybe it's odd. Well, I just found g of negative x. It's right here. So now let's see if maybe that might be equal to negative g of x. Well, what does that look like, Miss Griggs? Well, if I know that g of x equals x cubed minus 1, what would happen if I made it a negative? Well, negative g of x would equal negative x cubed minus 1. Notice that I put the negative outside the whole thing. Now the whole function is negative. So negative g of x equals negative x cubed plus 1. So I am distributing the negative. So let's look at it now. Now I've got negative g of x. This is equal to negative x cubed plus 1. Is that equal to g of negative x? No, because this is a negative right here. The 1 is negative. So guess what this means? We do not have even or odd. It's neither one. Okay, moving on to number 3. So now I have h of x. Well, I'm going to find h of negative x first. I'm always going to do this first. So that gives me negative x to the 5th. Remember, anytime a number is raised to an odd power, it's going to keep the same sign. So if it's positive raised to an odd, still a positive. If it's negative raised to an odd, still positive. Or sorry, still negative. Out of control. All right, babies, so here's the deal. Here's my positive h of positive x. Here's my positive h of negative x. Are those two the same? No, one of them's positive, one of them's negative. So we do not have y-axis symmetry, and this is not even. Let's see if it's odd. Well, I've already got h of negative x, so let's find negative h of x. Oh, look at that. When you put a negative in front, those are exactly the same. See, these are equal to each other. Negative x to the 5th and negative x to the 5th. That means we have origin symmetry, and that means the function is odd. Very good. Now, since students struggle with this, I'm going to do one more video over this with a few extra examples. If you feel good about this, no problem. You don't need to listen to the other video. But if you're struggling and you think you may need some extra help, listen to the next video.